So as you'll remember, we kind of have already talked about photochemical smog, and photochemical smog is caused when NOx and VOCs, or again, the other name for those is HCs, and the presence of sunlight, they can react and make this ground level ozone. And why this is significant is, again, this ground level ozone is what is associated with photochemical smog. So photochemical smog. So this is a big equation, a big thing to remember. To take care of this ground level ozone, this ground level ozone is a secondary air pollutant. What that means is it is not released directly from cars or combustion of coal or anything like that. It is formed in the air by the reaction of the NOx, the HCs, in the presence of sunlight. Therefore, we cannot reduce ground level ozone directly. We have to either reduce the nitrogen oxides or the hydrocarbons. And so in urban areas where there are a lot of cars, because again, NOx comes from combustion at high temperature and pressure. The engine takes in nitrogen gas from the air, oxygen gas from the air, and makes NOx, NOx. And this is, again, this occurs in an engine, which is at high temperature and pressure. So basically, any engine is going to have NOx being released. So if you have an engine, you have NOx being released. If you have gasoline, those gasoline vapors are going to release some hydrocarbons. And so urban areas, you have lots and lots of photochemical smog. So in order to reduce photochemical smog in urban areas, one method to reduce it as a catalytic converter will reduce your NOx, but to address the HCs, the hydrocarbons, is a vapor recovery system. So a vapor recovery system basically started with what you see up here on this gas nozzle. And you see kind of these little holes here in the side. Those little holes are basically when you would put this in to fuel the car, the gas comes out here, the gas, like the liquid gas, okay, your gasoline, I should say. And then what happens is there's vapor that is getting pushed out of the tank. And the purpose of those little holes right there is to take in those gas vapors. They actually take the gas vapors out of your car. So when it's getting fueled, the gasoline is getting put in and vapors are coming out of your car. And then those gas vapors, and that's what this next image is showing, is those gas vapors then are put back down into the gasoline tank. And so this way they're not released into the air. So this is the idea of a vapor recovery system. Then when the truck comes, and so it could be, again, this is showing a train car. Otherwise, it could be like around the Chicago area. Again, it's going to be a lot of, trucks coming to deliver the gasoline to the station. What happens then is when they're coming and they're getting their fuel intake, okay, so when the fuel is flowing in, then they are going to be pushing their vapors into the vapor recovery system at the petroleum terminal. And as I look more at this image, it doesn't actually show it that great, but here's the vapor recovery system. And very often what they do is they just burn off. So sometimes you'll go by a gasoline terminal and you'll see a flame, and they'll be incinerating or burning off those gasoline vapors. Sometimes they'll actually condense them back into gasoline again so that it can be sold. So either way that is happening, but the big idea is to capture the HCs so they're not released into the air. And by reducing the HCs, so we're going to reduce those, we're going to reduce photochemical smog and the secondary air pollutant of ground level ozone. So a vapor recovery, they were kind of legislated to be more in areas where where the ground level ozone was high, so where photochemical smog was high. In other words, in cities, that's where it was mandated to be since 1994. But basically now they're not requiring that as much because as of 2006, all new automobiles and light trucks are equipped with their own onboard vapor recovery system. And so since they have it's like a canister in it, and it's going to kind of recover the vapor a little bit. They're now not requiring that as much at gasoline stations. But where all this comes from and why all this is this way is to reduce ground level ozone or photochemical smog. Hope that was helpful.